All right. So again, what we're going to do today, we're probably going to finish up chapter 2. We might even get a little bit of review in today. What we'll do for an exam, I'll have to set up a time for that. And what I'll probably do is just have a window of time where you can do the exam. And just talk to my colleagues, find out what would be an appropriate window of time, and then go from there. I'll let you know about that this afternoon. I'll get that sorted out. What we're going to do is we're going to pretty much just do section 2.5. And if I've got some time, probably do a little bit of review. So excuse me, for the sake of time, let's get started on, unless you have any questions. Well, then I'm going to get started, but if any questions come up, let me know. So what we're getting into is what's called the point slope form. Now, we talked about lines earlier. And what lines are, they're basically, they're a graph that doesn't have any curves in it. Just continues on in one direction, continues on in the other direction forever. As for the equations of lines, we've learned about 2 types. There's what we call standard form. And then we have this one, what is slope-intercept form. Now, for graphing lines, and I didn't mention this last time, but when we graph a line, we need at most and at least 2 points. We need at most and at least 2 points. Once you have 2 points, you can graph a line. You're all set. Now, 2 common types of points to use are the intercepts of your x and y intercepts. And then with your intercepts, well, this is where a line crosses the x-axis and the y-axis. Now, the way you find these, for the x-intercept, you let y be equal to 0 and solve for x. So, for example, let's say we have a line in slope-intercept form. The x-intercept will let y equal 0. And then we're going to solve for x. Okay, x equals 2. So this tells us this line crosses the x-axis at x comma y equals 2, comma 0. So that's how I find the x-intercept. Now the y-intercept. Let x be 0. So y equals 3 times 0. Subtract 6. Y equals 0 minus 6. Or y is negative 6. So that means the y-intercept is 0, negative 6. So now to graph this line, only graphing part of the Cartesian plane here, piece of the window. The x-intercept was 2 and 0. The y-intercept, 0, negative 6. And once we have 2 points, we have all that we need to do the line. And that would be a graph on a line using the intercepts. Questions about that? So that's one way of doing things. We also talked about slope. So slope, you can think of it one of 2 ways. Now we always move left to right. So this would be a rise and a run. So our slope m is rise over run. Or we can think of a negative slope, where we're dropping. The line is traveling like this. Here it's traveling like that. So this would be a fall and a run. And again, the run is always left to right. At least that's how we typically look at it. There is a way of treating it differently, but it helps to work in one direction, usually. And for the fall, a fall is going to be negative. In other words, your change in height is going to be negative in this case. Now we looked at what we call the slope formula. give you a second to put in your notes. But that's this idea of slope. Lines have slope. It's how they change vertically as you move from left to right. Now, we have a slope formula. So let's say I have a line doing this. So we have this line. It's passing through these 2 points. Now, what I recommend is labeling the points. X1, Y1, X2, Y2. Now, for ordered pairs, again, X is always first, Y is always second. And when I come up with these little subscript numbers, we call those subscripts. So this X isn't confused with this X. I'm going to choose one of these points to be the ones point or the twos point, or the first point, second point. And when I make that choice, if I say this is the first point, I want to make sure both my subscripts are 1. If I choose this point to be the second point, both subscripts need to be 2. Now, I could have done it backwards. I could have made these 2s. I could have made these 1s. But the thing I don't, and that's totally fine. What you don't want to do, don't call this a 1 and that a 2, or this a 2 and that a 1. Don't mix things up like that. But you can call these 2s, you could call these 1s. That's perfectly fine. So the formula. Y2 minus Y1, X2 minus X1. And that's going to be our answer. So another way you can interpret it, we could say that M is rise over run. Now this is -2. So -2, we'll call this -2 over +1. Because you can always divide by 1. And then the -2, we always want to put the negative on the top. That's just a standard thing to do. So what this says is that our rise is -2, which really means we're falling. A rise of -2 and a run of 1. Or, put another way, we could say a fall, where we're dropping, of 2, run of 1. We can think of it like that also. So any questions about that? One last thing to review before we get into the last section. A little specific with this one. Now, I mentioned it earlier. This is the slope-intercept form for a line, where this is the slope. And this here's the y-intercept. Zero comma. Now, from this equation, we don't get an x-intercept. We have to solve for that. But we are given the slope. We are given the y-intercept. Questions about that? So I do want to mention one last thing that we didn't talk about last time. Graphing with y equals mx plus b. So how can you do this? You can actually use this technique to graph with any slope and any point. Well, not any point. It's any point on the line. I want to show you a trick how to essentially generate a second point using the slope and a first point. So you can generate a second point using a slope and a first point. So this is how this is going to work. So let's say we have a slope. And for the sake of argument, just to make it a little easier, we'll say it's a rise over a run. So let's say we have a point on a line. We have x1 and y1. Now to actually draw this line, we need a second point. So this is how we get it. So this will be x1 plus the run. And then here will be y1 plus the rise. Then that will give us, pardon my artwork, do this. I'm going to redraw this so it's a little more accurate. This will give us our second point. So what we do is we start at x1, and then we add the run. So we go over how many units are in the run. And then we're still at y1. So we rise up the amount of units that are in the run. And that'll give us our second point. So let me give you some formulas. And I'm going to do an example. And I'll do the example two different ways. I'll do the example numerically, and then I'm going to do it graphically. And this will work for y equals mx plus b. We'll do an example of that one too. In fact, we might do that as our second example. So the equations is that if you have if you're given a point and you're given a slope, it could be a rise or a fall, then what you're going to do x2 will be x1 plus the run. And then y2 will be y1 plus the rise. Or if it's a fall, you're going to be adding a negative number. So you could technically call that subtraction. But we'll treat fall as a negative rise. So you don't have to keep going between rise and fall. Pardon me. So these are going to be the key formulas for generating that second point. So I'm going to do some examples. Any questions so far? I'll give you a second to update your notes. Now, for example, let's say we have a slope of -3/2. And we have a first point of 2 and 1. Well, first off, we want to work with this slope. It's got a negative. We want to move the negative to the top number. And so this will be the rise. And that's going to be the run. So for our second point, the x2, x1 plus the rise, or 2 plus -3, that's going to be -1. Any questions about that? Now for y2, it'll be y1. Oh, I'm sorry. plus the run. Sorry, I made a mistake. Just had lunch, and I think what's happening is all the blood in my stomach. I mean, the physiology of digestion sort of robs you of. Anyway, let me fix it. I think I just had lunch, and when you eat, your body puts all the focus on the stomach, and it draws resources from other things, probably including the brain. It's x1 plus the run. So in this case, the run is 2. We're going to get 4. Now for y2. Yeah, I apologize for that. This is y1 plus the rise. And again, we're going to let the rise, if it's positive, it's a rise. A fall, we'll just call that a negative rise. So this will be 1. And then our rise was really a fall of 3, or we can call it a rise of negative 3. This will be negative 2. So we've had a slope, we have a first point, we used our formulas to get our second point. So now we've got our 2 points. Now we can graph this thing. So 2 and 1, 2, 1, so it's right there. 4, negative 2, 4, negative 2, put us right about there. And then once we have 2 points, that's the minimum we need to draw a line. And I'm just going to connect these 2 points. And that's going to be our answer. So that's a way you can graph starting with 1 point and the slope. Now this is the numerical way. I want to show you the graphical way. So any questions about this? So let's say we're given this, y equals 2x plus 1. Now our slope is equal to 2. And this is the y-intercept. This will be 0. Y-intercept always has the x of 0. It's 0, comma, and there's the 1. That's where that 1 goes. Now let's take a look at the slope. Well, since it's a whole number, we want to rewrite it as a fraction. So we have 2 over 1. This is our rise. Bottom number is our run. Now, we do actually have a first point. If you wanted to do this numeric, what you could do is we can call this x1 and y1. That's perfectly fine. So I'm going to do it numerically and graphically. So x2 is x1 plus the run Or in this case, x1 is 0 plus 1. That's going to be 1. y2, well, it's going to be y1 plus the rise, or 1 plus, and our rise is 2, and we're going to get 3. So that means the second point, x2, y2, is 3, I'm sorry, 1, comma, 3. So we actually have 2 points. We have the y-intercept, and we have our second point. So we can graph it like so. So the y-intercept is 0, comma 1. And then the point that we came up with was 1, comma 3. And so that's how we can graph that line. So this is the numerical way of doing it. Let me show you the graphical way. And if I'm going too fast, let me know. So what we can do is let's identify our y-intercept. Now again, this is 0, 1, and that's the y-intercept. This here is the slope equals 2, or 2 over 1. Again, we want that rise over run to stand out. So what we'll do is this. There's our run. There's our rise. So we'll start with the y-intercept. In fact, I'm going to make this red. Because we're going to use rise, run, and the y-intercept. So to generate a second point just using a graph, we have the run, which is equal to 1. And remember, run always goes left to right. So that means we're going to go over 1 unit. And then now we're going to rise up 2 units. And we rise up because this is positive. If the rise was negative, instead of going up, we would drop down. So let me make a note. a rise less than 0 means drop down. So once we've done the run, once we've done the rise, where we stop, that's where you put that second point. And then connect the points. And that's how you can do this graphically. Questions about that? And again, this will work with any point that's on the line. It has to be on the line. Any point on the line and the slope of that line. You can graph this way. So let's talk about 2.5. So what we're talking about in 2.5 is what's called point slope form. So there's basically 3 forms of a line we're going to be looking at, plus a couple special ones. We have standard form, slope intercept, and then the point slope form. And the point slope form works this way. So what we know is this. There's a point that we know. We have a slope. And we're going to pick out a variable point. Or in other words, a point that's on the line, but it could be any point on the line. So this is a specific point. We have the slope for the line, and the slope never changes on a line. The slope will be the same everywhere on a line. And we're going to pick some random point. We could have picked it here, 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 but we picked this one here. The only requirement we have, you have to pick a point that's on the line. So this is what we're going to do. We have x1, y1. I'm going to call this x2, y2. Now, I don't know what x2 and y2 are in this case. There's still a variable point. Like this is a point we actually know. We actually have numbers for this. In the examples, I'll show you what I mean. This is something we have a number for. These we don't have numbers for. Now, the reason why I'm labeling them is I'm going to use them in the slope formula. So slope, y2 minus y1 over x2 minus x1. So now I'm going to plug in by x1 and y1, the points that when we get to these problems, we're going to know what they are. Well, I'm going to plug in those. And then I'm going to plug in these variables for x2 and for y2. Let's see what that does. And we're going to have a number for that also, ultimately. So it will become this. Because y2 is representing that variable y. x2 represents this variable x. So here we go. What I'm going to do, I'm going to solve for, and I'm going to switch things around. This is the same thing as this. I just put the m on this side and the big ratio on the other side. So what I'm going to do, I'm going to multiply both sides by x minus x1. Now, since I'm dividing by x minus x1, if I want to cancel that or make it go away, I have to undo it. So if I'm dividing by this, if I multiply by the same thing, well, that will undo the division. Again, like if I'm dividing by 2, I can undo that by multiplying by 2. But what I do to one side, I have to do to the other because of the equal sign. So we have a multiplication, we've got a division by the same kind of thing. Well, those will go away. We're going to be left with this. And this is what's called the point slope formula for a line. Now, why do we have something like this? So what? Well, the idea is this. We were given before, in the graphing examples we just did, we're given a point, we're given a slope. Can we generate a second point that lets us graph that line? And we can. We can use those formulas for x2 and y2. Or we can take one of the points in the slope, got a point here, there's a run, there's a rise, there's your second point, draw the line through. So given a slope and given a point, we can come up with the graph of a line. But we might not want the graph. If we're given a point and a slope, maybe we want the equation for the line instead. And that's what this does. So if we're given just a slope and a point, now we can find the equation of the line and not just the graph. So that's the thinking. Let me give you a second to update your notes. All right. Again, if I'm going too fast, let me know. So for example, let's say we're given a slope of -3/2. And let's say we're given a point I don't know, 2, 1. Now, we know how to graph this. We can use those formulas where x2 is just x1 plus the run. y2 is y1 plus the rise. And that will give us x2 and y2. So we graph this, we graph x2 and y2 then, and we connect the points to get the line. But now we're looking for the equation of the line. We're going to have this. Now, the important thing to remember, we have a number for this, and for that. But we don't have anything for y and x. We're going to leave it that way. We don't try to change that. This will always just be y. This will always just be x. So now we do our substitutions. So y1 is going to be 1. M is -3/2. We have x minus, and then x1 will be 2. Now the next thing to do, distribute -3/2. So we get -3/2 x. Negative times negative, that means we're going to have a positive. 3/2 times 2, that actually is just 3. 3/2 is 1.5, so 1.5 times 2, well, that's just going to double 1.5. That gets you back to 3. So finally, we're going to solve for y. Because when we do this, we usually aim for slope-intercept form. And all that means is solve for y. Add 1 to both sides. Y, -3/2 x plus 4. So for our answers, we're going to put them in this form. We're going to solve for y, or what we call the slope-intercept form. So questions about that? So this is a kind of a favorite, and I can guarantee you this would be on the test, the following problem. This will probably be on there too, but look at this one. The equation of a line passing through these 2 points. Now this seems kind of problematic because so far, to come up with the equation of a line, we need a point and a slope. Well, we have 2 points. It doesn't matter which one we choose actually, but we need the slope. Well, the good news is we know how to calculate a slope using 2 points. So what I'm going to do, again, just so I don't mix numbers up, okay, that's x1, y1. This is x2, y2. So for my slope, I have y2 minus y1, x2 minus x1. So this will be 2 minus 3. And this will be 5 minus 6. Double check my math here, make sure I've got things going in the right place. So far, so good. And again, I could have called this x2, y2. I could have called this x1, y1. That's fine. I just don't want to go like x1, y2 or x2, y1. That's where things go wrong. So we'll get -1 over -1. Negative divided by negative is positive. We get a +1. So that's our slope. Now we're good to go. We can use the point slope formula. Now that we know that m is 1. Now we could use either this point or this point in the point slope formula. Either one will work. But I'm just going to stick with this one. It doesn't seem to be, the numbers here aren't any harder to work with than these numbers. Why would I use maybe these instead of these? Well, if these were fractions and these were whole numbers, just to make life easy, I would probably use the whole numbers. So I would put this one for x1 and then this one for y1. But don't have to really do that in this case. I mean, everything, all whole numbers. So I'm just going to stick with the x1 and y1 I've already chose. So I'll get y minus 3, and then 1 times x minus 6. 1 times this thing, nothing changes. Add 3 to both sides. And then -6 plus 3 is negative. And that's going to be your answer. Questions about that? So that's a very popular problem for an exam, just FYI. And it brings everything together. Well, for the rest of the class, it looks like we will need the whole thing. We won't be able to get to any review today. But for the rest of the class, I want to talk about just some things about slope and special kinds of lines. So again, when we think about slope, we think about it going left to right. So this would be a positive slope. This here would be a negative slope. So sloping up for positive, sloping down for negative. A perfectly flat line. This is a slope of 0. And then a perfectly vertical line. Let me make sure I'm doing this vertical. It's pretty good. This slope is undefined. Now we've been working with these, and we've been working with these. We're going to take a look at these next. We'll start with this one, the line with a slope of 0. Horizontal line. So this is a line that's perfectly flat. And the slope is equal to 0. Now it has a special form. Or a special equation. And it's y equals b. So to give you some examples, this crosses the y-axis at 1. So the equation for this horizontal line is y equals 1. Now, down here, let's say this horizontal line crosses the y-axis at -2. So this will have the equation y equals. Questions about that? Just minding the time. So vertical line. So vertical line look like this. And the slope is undefined. Now these also have a special form. X equals A. So what do these look like? Well, say we have this. Now, if I have a vertical line here, well, this passes the x-axis, passes through the x-axis at x equals 2. So the equation for this vertical line is x equals 2. Then here, let's say I have a vertical line passing through x equals -1. Well then, the equation for this vertical line is x equals -1. So that's our vertical and horizontal lines. Now there's a way these things come together with plotting points. And we've already sort of hinted at this. So let's say we have xy is 2, 1. Well, this is x equals 2. And this is y equals 1. So you have a vertical line, x is 2, and a horizontal line, y equals 1. So we have a vertical line, x is 2. We have a horizontal line, y is 1. It's y equals 1, x equals 2. And where these intersect, well, that's 2, 1. So that's been our method for plotting points. Now there's another way of plotting points, and I do want to talk about this on Thursday, because I think this is a clunky method of doing it. It's really there's an easier method using the way we graph slopes, or while we generate a second point using slopes, where we start from 0, we have an x is 2, we'll go over 2, y is 1, go up 1, plot your point. I think that's an easier way, at least that's my opinion. If you prefer this way of thinking about it, keep it that way, go ahead. The last thing to mention in this section are parallel and perpendicular lines. So for parallel lines, they have the same slope. Now looking at the text, there's one thing with vertical lines, they're also parallel. This might seem kind of strange, why to mention vertical lines specially, because don't vertical lines have the same slope? It's the slope that's undefined. Undefined can actually refer to a lot of things. It's undefined. It can be undefined for many different reasons, I suppose you could say. So just to be careful, we say that lines that have the same slope, they're parallel. And then vertical lines, they're included. It's kind of obvious looking at them, but you just want to be careful. So some parallel lines, they look like this. Or for vertical lines, you would see something like this. And horizontal lines too. They have the same slope of 0. So that's the idea with parallel lines. If you want, think train tracks. Train tracks are parallel. So now we've got this idea of parallel lines. So a common question is this. Find a line parallel to y equals 3x minus 7. Find a line parallel to y equals 3x minus 7. So the only requirement for parallel is same slope. Any line with the same slope, m equals 3. So we can come up with all kinds. The easiest one, y equals 3x. Now remember, it's got to be 3 times x. Y equals 3 doesn't count. That's a horizontal line with a slope of 0. Got to be 3x. We could do y equals 3x plus 13. Y equals 3x minus the square root of 2. As long as we have 3x, we're all right. Any of these would be our answer. For a homework problem or for the test, they're just going to ask you to choose one. Perpendicular line. Now, these are lines that form a perfect cross. Another way of thinking about them is they intersect at 90-degree angles. So examples of perpendicular lines, they might look like this. Or maybe this. So these would be perpendicular lines. So what's going on here? Well, there is a relationship between the slope of this line and the slope of this line. For the vertical line, this one's undefined, and then this one would be 0 for a horizontal line. But for lines that aren't perpendicular and horizontal, say something like these two, there's a special relationship. So the slope of the second line equals the reciprocal of the slope of the first line made negative. So this is the special formula. higher my red pen. So slope of the second line, slope of the first line. So let me do an example. So I want to find the line perpendicular to y equals 3x minus 7. Well, first off, identify your M1. That's the slope they give you. So now we put this in our formula. M2 is minus 1 over M1, or minus 1 over 3, and we could just call this negative 1/3. Again, with fractions and negatives, usually put the negative in the top, or we'll put it out in front of the entire fraction. So we need to come up with an equation of a line. Now this is the slope. So the easiest equation we could come up with would be minus 1/3 x, or minus 1/3 x plus 8, or y equals minus 1/3 x minus the square root of 10, and on forever. But any of these would be our answer. They would work. So any questions about that? So that's pretty much it. That's pretty much it. We've covered the material for chapters 1 and 2. That means it's test time. I'm not going to do a test on Thursday. What I'm thinking of doing is doing a review, and let me again talk to my colleagues, see what we're going to do about the test. I mean, I might just open it up over the weekend. Like, you need to do it starting between these two starting times. Somewhere in there, you need to log in and do the test. Let me just finalize the details for that, and then that's it. So if you have any questions, let me know, and then I'll be starting office hours in about 14 minutes. So if there's something that you realize, oh, I wish I would have asked this, and he's gone, I'm not. In the class Blackboard link, go to start here, and then scroll down and look for office hours. Click on that, and that's where you're going to find office hours. So again, if you have a question, ask me now, or if you want, you can wait to office hours.
So do we have a test today?
Not today. No test today.
Okay.
Yeah, don't worry about that. We just finished chapter 1 and chapter 2. So what I'll probably do, I'll think, well, let me see about a review. There's different ways I might handle that. I might do a video review and post it. And then I might lecture on chapter 3 on Thursday. I'll have to see. I need to take a look at our times and make sure our schedules are okay. But what I'll probably do is I'm looking to open up the exam probably as early as this weekend. And I just have to verify with my peers if that's going to be okay, and go from there.
Okay, thank you.
Yeah, no problem, no problem. Other questions?
So the tests that are due on Tuesday and Thursday, we don't worry about those, or?
Those are quizzes. Quizzes you want to do. You do want to get the quizzes done, but the exam is a totally different thing. We're going to do an exam that covers chapter 1 and chapter 2, and that's going to be a big cumulative thing. The quizzes are just sort of sectional. They're just sort of there to help you review. And careful with the quizzes, though. Unlike the homeworks, you don't have unlimited tries on the quizzes. So just be careful when you do your quizzes. That I think you have like maybe 3 attempts per question. So you want to really make sure you look at what you need to do for the problem and before doing the problem. Take a look at it, make sure you've got it understood and carefully work it out.
Okay, thank you.
No problem. Other question? Well, I'm going to log out. I'll be in office hours at 2:30. And other than that, have a wonderful afternoon.
Thank you, you too.
No problem.